Okay, we're going to be looking at practice test 2, second half, problem number 3. We have a bungee jumper. He's going to jump from a ledge. The bungee cord unstretched length is 20 meters. And we're asking the question, how far below does the jumper come to a stop? Um, so the bungee cord is going to stretch some distance y in addition to its unstretched length, 20 meters. We're going to take as our system the person, earth, and the bungee cord, and we'll consider it an isolated system. As with all the problems, if you want to get the best out of it, attempt to solve or answer any question I ask or problem I pose before you continue the video. Okay. Is there any work that transfers energy into or out of the system? No, it is an isolated system. The person, earth, and bungee cord form an isolated system. What is the conservation of energy equation for an isolated system? Well, the person starts off with some gravitational potential energy. In the process of motion, he may have some elastic potential energy and some kinetic energy. So whatever change takes place in the gravitational potential energy, the elastic potential energy, and the kinetic energy must all sum to zero. There's no energy being transferred out of the system. What is delta K when the bungee cord brings the jumper to a stop? Of course, delta K is zero. What does the conservation of energy equation, this equation here, reduce to in the case of delta K equals zero? Of course, the change in gravitational potential energy plus the change in elastic potential energy has to equal zero. What is the change in gravitational potential energy? Well, we're going to look at the gravitational energy in the final position minus the gravitational potential energy in the initial position. Of course, the gravitational potential energy is taken as zero at y equals zero, and the loss in potential energy is y plus 20. And so our final number will be minus mgy minus mg times 20. What is the change in elastic potential energy? Change in elastic potential energy is the final elastic potential energy minus the initial elastic potential energy. The initial elastic potential energy is zero. It's unstretched, and it stretches by y, so the final elastic potential energy is 1/2 ky squared. Solve for y, we want to put these terms in the equation, the conservation of energy equation, this equation right here, and solve for y. When I do that, I'm going to have 1/2 ky squared minus 1 mgy minus mg times 20 equal 0. And if you'll notice, this is a quadratic equation, which we can then substitute the numbers in here for. Substituting the numbers, and remember that quadratic equation, y will be equal to b squared, well, let's correct that, minus b over 2a plus or minus the square root of b squared minus 4ac over 2a. And we can then solve for the final number. And that's 44.7 meters is how much stretch occurs. The The total distance that the person falls is the 44.7 plus 20 meters, which that'll be 64.7 meters. And we're done.